Hi, welcome back to my channel. So today we'll be going through 2024 P5 Science end of year Singapore Chinese Girls School question number 40. So this question is on water processes, specifically on melting and freezing. So the table shows the melting point of 3 different chocolates. So you are giving X, Y, Z. The melting point are very different. So page 3 place a chocolate cube on a heating plate at 40 degrees Celsius. So this heating plate, right, will heat up the substance up to this temperature at 40 degrees Celsius. Okay, the chocolate cube turn into liquid after some time. That means at first, right, it's actually a solid cube because over here, right, this is has a fixed shape, so it must be solid. So they are trying to tell you solid become liquid, it must be melting. It must be melting, right? So based on the information, which type of chocolate could be the chocolate cube made of? So which of these is a cube that actually melt into liquid? They're asking you to make a choice. Okay, so in this case, so basically you are given a melting point, right? You are supposed to find out which substance exists as liquid at 40 degrees Celsius. If the substance exists as solid at 40 degrees Celsius, right, you don't choose. Okay, you only choose those that exist as a liquid state at 40 degrees Celsius. So this is what I'm going to do. Since I already have this melting point, right, I'm going to draw a line. In this case, this will represent a temperature line or number line. So over here, this will be the smaller number, smaller. This will be a larger number. Okay, and I'm going to use 32, 41, and 54 for the reference point. In between, I'm going to draw one line across down, and I'm going to tell myself that this will exist as a solid state. Okay, let me use green color, solid. Then this will exist as a liquid state, blue color. So any number that fall into this region will be solid. Any number that fall into this region will be liquid. So then I will ask myself 40, where should I put it? 40 versus 32. Okay, I should place it on the blue color side because it is larger than 32. So that means, right, X at 40 degrees, right, X is a liquid. Okay, what about the rest? Okay, 41, so it should be here. That means at 41 degree, Y is actually a solid. Then for the last one, it will be here, 40 then 54. So that means, right, between these three substances, right, at 40 degrees, these two will become a solid or remain as a solid. This one is the only one that become a liquid. Okay, so how do I explain this? Okay, based on the information, which type of chocolate could be the chocolate cube that made of that cause it become a liquid state at 40 degrees Celsius? So very simple. Okay, X, and we use the evidence over here. We use the evidence because why? The melting point of 32 is lower than the surrounding temperature or the temperature of the heating plate. Okay, therefore X will melt into a liquid. X will melt into a liquid. Okay, in this case. Okay, so this one pretty straightforward. Okay, for this part. Okay, the key is lower. Compare. Okay, so page 3 make another chocolate cube of Y and Z in a setup as shown below. So, then they tell you that Y and Z is made up of this is part of a chocolate cube. Okay, then you got a tank, you got a heater, then you got a container. She want to obtain liquid chocolate that's made of Y only. Liquid chocolate that is made of Y only. That means actually over here I want only Y to melt. Z, I want it to become I don't want it to melt, so I want it to remain as a solid state. Okay, explain how she could use the setup to do so. Explain how. Okay, so there's an action, then there's a reasoning. The action is that, right, you got to rely on the melting point again. That means you want to choose a particular temperature, right, where Y will exist as a liquid, but Z will continue to exist as a solid. You want to choose that particular temperature. So let me put it down over here. This is the melting point is 41. The melting point for this is 54. Okay, so in this case, right, if I were to draw this, right, okay, 41 Y at 41. Okay, Z is slightly higher, so it's above the number line. So Z is at 54 degrees Celsius. So that means, right, I must choose a number that most likely exists over here. Okay, exists here, this part. Because any number that exists at this point in time, right, Y will become a liquid. Z will remain as a solid because it's below the melting point. Okay, but a number that is over here is higher than the melting point of Y. So Y will become liquid, Z will become solid. Okay, so what should you do? Basically, you quote this number. Okay, quote this number 41 to below 54. Okay, 41 to below 54. That means right, you can choose 53 degrees Celsius. Okay, because at 54, right, it will melt. 54 Z will melt, so that's why you cannot choose it. So how do I write it? Okay, you can say heat the chocolate cube between 41 and 53. Okay, between 41 and 53. So in this case, it must be below 54, because if you choose at 54, right, Z will melt also. You don't want Z to melt, you want Z to be remain as a solid state. Then what happens is that the Y, right, will just flow out into the cube, while Z will remain as a solid over here because it has a fixed shape. Okay, so reasoning is that at the temperature range of 41 to 53, okay, Y will melt into and turn into liquid, while Z will remain as a solid. Or you can say only Y will melt while Z will remain as a solid for this part. Okay, so this one pretty straightforward. So okay, the last part, the diagram below shows how to make an ice cream with a solid chocolate coating. Okay, so you have an ice cream and you have a cone. Then after that, you dip it into the liquid chocolate. Then it becomes a solid chocolate coating. Then they ask you how the solid chocolate coating is formed on the ice cream. How come this thing will form? Okay, so you got to look at this. Actually, this is an example of some of you may have eat this ice cream before. It's called a ChocoCone. It's from McDonald's. Okay, McDonald's always have this kind of product, and some of you might have eaten it before. And if you have looked at how McDonald's do it, right? So what did McDonald's do? Okay, so you got a vanilla ice cream cone first over here. So this is the first step. Okay, maybe I write it down here. This is the first step. Then the second step, they do what? They dip it into the liquid chocolate. So what happened? The ice cream, right, which is very cold, the temperature is very low, the ice cream cone. Okay, so what will happen? It will gain heat from the liquid chocolate. Then the liquid chocolate will now lose heat. Okay, it will lose heat to the vanilla ice cream, or the ice cream itself. It will lose heat. Okay, loses heat. Then once it loses heat, what will happen? It will then become in this way, right? Okay, it will start to freeze. Okay, freeze. It will start to freeze, and then from there, when it freezes, right, it has a fixed shape, so it will wrap around the ice cream cone in this case. So this is the second step. This is the third step. Okay, you leave it long enough, you take it out, then this will be the final step. Okay, step 4. Then you have a solid ice cream cone. Okay, in this case, okay, where it has already freeze into your solid state. Okay, so you can see that at first it's liquid. Okay, so because you put the ice cream in, it loses heat, then it freezes, then it becomes a solid in this case. Okay, so that's actually how it actually kind of forms. So the main idea is lose heat, or rather, let me just highlight is lose heat. Okay, the main idea is lose heat and freeze. Okay, then it becomes a solid. So how do you explain this part very fully? Okay, so you can talk about the liquid chocolate loses heat to the ice cream. Okay, which has a very low temperature in this case, and freezes into your solid. Okay, for this part, and that is actually how you can have your solid chocolate coating on top of the ice cream cone in this case. So with that, okay, let me just review the top part. Okay, with that, then this is the second part. With that, thank you very much.